Hi, so I'm Meditya Vasesa. So in this session, we are going to discuss the task of hypothesis test concerning comparing the means of two independent populations using the t-test. Yeah. Okay. So the situation is like this. Yeah. So we have two different populations, and then we have the mean value, the hypothesis mean value of each populations, and then we want to test whether the mean of population 1 and the mean population 2 are similar, yeah, or whether the mean value of population 1 is larger than population 2, or whether the mean of population 1 is smaller than population 2. And what we do is we pick data points from population 1 as samples, and then we calculate their statistics, yeah, the mean and standard deviations. And also similarly for population 2, we pick several data points, yeah, from population 2 as samples, and then we calculate the sample mean and standard deviations. And in principle, we would like to see whether the calculated statistics from each sample, yeah, from population 1 sample and population 2 are indeed close to each other, which indicates that the mean are similar, or farther away. Yeah. Okay, that's the principle. And then the assumptions of using the t-test for output variance is, the data points or the respondents that we pick for the samples are randomly picked. Yeah. So there is no intentional cherry picking the data points. For example, we intentionally only filter in the respondent who has higher salary or lower salary. No, we don't do that. Yeah, we randomly pick the respondents or the data points. Yeah. And then the second and the third assumptions is that we assume that the populations of each population 1 and population 2 are randomly distributed, are normally distributed, excuse me, and the populations have equal variances. Yeah. And then the fourth one, yeah, if we cannot assume that the populations are not randomly distributed, then the sample size, yeah, or the number of respondents or number of data points that we have to take should be larger than 30 points. Yeah. Okay. There are two instruments that are important in conducting this t-test execution. First one is, of course, the table, the t-table. Yeah, this one is important to determining the region of rejection and non-rejections. Yeah, the critical value, which will be then determined by the degree of freedom and significance level that we will pick. And the second one, the second instrument that is important is the formula for calculating the t-statistics. Yeah, we will delve into this, into the usage of both the t-table and the calculation of the t-test further on with the discussion of the problem set. Okay? Okay, let's go directly to the problem set elaborations. Yeah. Okay, here's a problem set that we have to uh, discuss. Yeah, determine whether there is evidence at the level of 0.05 significance that the sales of jamu temulawak are the same when the marketing booths are located in Raiso concert and are located in Kahitno concert. Yeah, assume that the distribution of both sales data are normal and standard deviation is similar. Yeah. So what the problem set asks us is, so assume that we are working for a large energy drink or jamu manufacturer. Yeah. So we are assumed to be the sales analyst, so might say. And then the energy drink company usually open a number of marketing booths. Yeah. And the two most prominent one is the one in one musician called Raiso, and the other musicians called Kahitno concert. And then they would like to check whether the sales at the Raiso concert and the sales number in Kahitno concert are similar or not. Yeah, but the claim, yeah, the first guess is that they feel that the number of sales in Raiso concert and Kahitno concert are similar. Yeah, that is the claim. Yeah, and that's what we have to verify through this t-test conduct. Yeah, so we have we have a sales data, the whole sales data from the Raiso concert. Yeah, with specific mean, population mean, and then we have also yeah, to check the mean, we pick several samples out of this Raiso concert, and also in Kahitno concert, yeah, the different marketing booths, yeah, in different concert, they have also sales data, but since the data records are too many, we pick only a sample of data, and then we will calculate whether the statistics are indeed supporting the hypothesis claim or not. Yeah. So in here, yeah, what we do to check the claim is we pick sample data points from Raiso and then sample data point from Kahitno concert. Yeah, here is the record. Yeah, from the Raiso concert, the first data points we write, okay, there are 22 sales. The following days, for example, 34 sales, bottles, yeah, bottles of energy drinks, and then 5 days later, 52 bottles are sold in Raiso concert, and so on. And we do also do a sampling of data also in Kahitno concert, and then we write down one by one. Okay, the first sales is 52, the second sales is 71, and so on. Then we have several data points that we will pick these data points as a sample. Yeah. Okay. So that's the problem set description. And then we now going to determine whether the claim is correct or can be accepted or must be rejected. Yeah. And what we are going to apply is the critical value approach to hypothesis testing, which includes six steps. First is the null hypothesis and alternative hypothesis statement. Second one is the level of significance and the sample size determinations. Third one, we have to determine the appropriate test statistics and sampling distribution. Fourth, determine the critical values that define the regions of rejections and the regions of non-rejection. Yeah. Five is to collect the sample data, organize the results, and compute the value of the test statistics. And based on the localizations of the test statistics within or excluded from the regions of non-rejections, we can conclude the statistical decisions and the managerial conclusions. Those are the six steps that we have to follow when we want to do hypothesis testings, comparing the means of two populations manually. Yeah, in Excel or maybe using statistical software like R, you can do it only by one line or two line of codes. But here we want to drill down to the fundament. Yeah. Okay, so let's go to the first steps. Yeah, state the null hypothesis and the alternative hypothesis. Yeah, the null hypothesis is, of course, as the problem set stated, that they infer that the sales, the mean sales of these energy drinks in Raiso concert are similar when they are sold in Kahitno concert. Or in other words, the null hypothesis, yeah, mu1 equal mu2, or the difference between mu1 or mu2, mu1 minus mu2 is equal to 0. Yeah, so that's the null hypothesis, yeah, the claim. And the alternative or the antithesis of the claim is, yeah, mu1 or the mean value of population 1 is not equal to population 2. Or in other words, mu1 minus mu2 is not equal to 0. So we have stated the null hypothesis and the alternative hypothesis. Okay, secondly, at the second step, we have to choose the level of significance, the sample size, and the degree of freedom. Yeah. The level of significance is already stated in the problem set, 0.05 or 5%. Yeah, it's provided in the problem set. The sample size, yeah, early on, we pick, let's see, yeah, just a moment, I go back. Yeah, so we can count, yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so N1, or the number of data points in the sample 1 is 10. Yeah, and in the data N2, or the number of data points in sample 2 is also 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so here we can state that yes, yeah, the degree of the level of significance is 0.05. The sample size of both sample size 1 and sample size 2 is 10, and then the number of degree of freedom is calculated using this formula: n1 minus n1 n1 minus 1 plus n2 minus 1, which equals to 10. Yeah, here 10 minus 1 plus 10 minus 1, yeah, which equals to 18. Then the degree of freedom equals to 18. Yeah, therefore the result of the steps 2, significance level is 0.005, sample size 1 is 10, sample size 2 is 10, and degree of freedom is 18. Okay, so now we go on to the third step, yeah, which is determine the appropriate test statistics and sampling distribution. Yeah, at the problem set, there is a statement that we can assume that the both population can be assumed as following normal distributions, and their standard deviation are similar. Thus, yeah, thus we can use the put variance t-test for the difference between. Yeah. So the type of test that we have, we can use in conducting the hypothesis testing is depends on the conditions of the assumptions of the populations. Yeah, here, because the population 1 and population 2 are assumed to be normal and their standard deviations is pretty much similar, we use this test. We can use this test. Yeah. Okay, going to the fourth step, which is determine the critical values that define the rejections and non-rejection regions. Yeah. So with alpha, or significance level of 0.05, but remember 0.05 or 5%, yeah, the hypothesis statement is similarity. Yeah. So mu1 equals mu2. That means that at the normal, the bell curve, yeah, so they want to seize the middle point. That thus the error point have to be divided in the right tail and the left tail. Yeah, here, yeah, so 0.05, because we want to see, yeah, whether mu1 and mu2, yeah, the difference between mu1 and mu2 is close to 0 or not. Yeah, we have to determine what t value here. Yeah, and then how to determine the t value. Yeah, in using the t, we in determine the critical value, we use the t table, and two parameters that there are two parameters that we require in determining the critical value. First is the degree of freedom, and the second one is the level of significance. Yeah, the degree of freedom we have calculated, yeah, from the second step. Yeah, so degree of freedom equal to 18. Yeah, and then the significance level 0.02, yeah, divided by 2, because it's two-tailed hypothesis statement, then 0.025. Therefore, to locate the critical value, we go to the degree of freedom, yeah, here 18, and then we go to the right side and find the significance level, the appropriate significance level. Here we can see 0.05, yeah, there is an intersecting value between number of 18, yeah, the degree of freedom, and the significance level. And then the value of the critical value is 2.1009. Yeah, it's 21.1009. Then we input it here as the critical value, yeah, plus 2.1009 and minus 2.1009. Yeah. This is the critical value that, you know, being the boundary between the region of rejections and region of non-rejection. Yeah. So because it's two-tailed, then the alpha or the significance is divided by 2. But if it's one-tailed, then you don't divide the level of significance. You can discuss this matter with your tutor later in the tutorial sessions. Yeah. Okay, so we have defined the critical value, which is plus 2.1 and minus 2.1. And then going to the fifth steps, yes, collect the sample data, organize the result, and compute the value of these test statistics. Yeah, in computing the value of test statistic, we use this formula. As we see, to calculate the t-statistic, we need the mean value of sample 1 and the mean value of sample 2, the number of the size of sample of number 1 and sample size number 2, and then the hypothesized value, and then the SP. Yeah, SP is the pooled variance, which have to be calculated using this formula. I will go to that in a minute. So we have this following sample data, yeah, with 10 data points. Yeah, we can calculate using Excel or manually the sample mean, standard deviation, and sample size. Yeah, we have 10 data points that therefore we use 10 sample size. Also for both population sample size 1, the rhizo conserved, and sample size 2, the chyno conserved. Then after that we can go. Firstly, we calculate the SP square value. Yeah, SP square value equals n1 minus 1. Yeah, multiplied by s1 squared plus n2 minus 1 multiplied by s2 squared divided by n1 minus 1 plus n2 minus 1. Yeah, so here n1, yeah, we can see n1 is 10 minus 1, then it's 9. Yeah, you can see 10 and then 9. Yeah, and then s1 square, as we can see, yeah, here s1 equals to 18.733. Yeah, or then we can pull this number to here and then we can square it. Yeah, then n2, of course, 10. Yeah, here we pull it here, and then also s2 square, we also pull the standard deviation number to here. Yeah, and then divide it by n1 minus 1, n2 by minus 1. This is 10 minus 1 equal to 9. 10 minus 1 equal 9. And then we have the SP squared value of 254. I'm sorry. Yeah. After we have the SP squared value, yeah, here, then we can calculate the t-statistics. Yeah, easy. Yeah, using this formula. Yeah, for x1 bar, then it's 50.3 here. Yeah, x1 bar minus x2 bar. This is 72, right? Minus the hypothesized difference between the mean value of population 1 and population 2, which is 0, because it is assumed as similar, divided by square root of SP square. SP square, we have a value here, and then we pull it here. Yeah, multiplied by 1 per sample size. Yeah, 10 and 10. And then here is the t-test value, right? So after we have, the output from the step number 5 is minus 3.0446. Yeah, so the value of the value of the test statistics equals minus 3.04. Okay, now we will go to the sixth step, the final step. State the statistical decision and the managerial conclusions. Yeah, here. Yeah, so we have at the fourth step, we have divided the critical value of the t. The value of t critical is plus 2.1 and minus 2.1. At the fifth value, we have calculated that the test statistic value is equal to minus 3.0446. And if we look here, minus 3.04 is located at the left side of this left critical value. No, thus, yeah, sorry, at the left side of the critical value. Yeah, sorry, excuse me. Yeah, or the t stat, yeah, lies in the regions of rejection. Yeah, because so minus 3 lies in the region of rejection. Thus, yeah, because the t stat value or the calculated test statistics is located within the region of rejection. Yeah, here. Thus, the hypothesized claim that state the mean sales both in Raisa and Kahitno consort that state that the mean sales are similar cannot be accepted. Yeah, that is the final statistical decision. Yeah, so the output of the whole analysis of the problem set is, yeah, because the t stat or the calculated t test is located within the region of rejection, thus the null hypothesis cannot be accepted. Okay, I think that's it. Yeah, for the discussion of the problem set, we will come back with the last section, which is calculating the confidence interval. Okay, see you in the next section. Bye.